Hello again. So this is page 4, example 4. So I'm going to start the same way. So -3, 1, 2, 3. It's a value outside the graph. But here's what I'm thinking. We know how to factor. I'll do the factoring later. I'm just going to substitute the -3 right there for the x squared. So I have 2 -3 squared minus 4 -3 minus 16. Okay, so I can use my handy dandy calculator here just to keep track of my math. So I have 2 times 9 plus I have -4 times 3 is 12 minus 16. So we got 14 there. Okay, I have -2, 0 right there, -1, -10, 1, -11, 12, 13, 14, 15, 16, 17, 18. So that's -18 right there. Oh, I'm not there yet. So 0, -16. 1 is right there, -18. 2 is right there at -16. 1, 2, 3, right there at -10. Okay, so which of the parabolas from questions 1 through 4 have a maximum value and minimum value? Well, okay, so the maximum is when you have a parabola that looks like this upside down, and the maximum is the point that is right there on the very tip top. So that's a maximum. And if you have a smiley face parabola like this, is when you start right there and you go down, 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 down. And the minimum is when you have your vertex right there in the bottom. Okay, so from the previous page, minimum values, it would be the parabolas from examples 1 and 4, and max with or maximum values would be parabolas 2 and 3. So which of quadratic function has a minimum value? Then a is the leading coefficient. A is the number in front of the x squared. So when a is greater than 0 or positive, then your quadratic opens up, or your quadratic is concave up. So, and the other way is true. So you have a maximum value, then your a is less than 0, or your leading coefficient is going to be a negative, and it's going to look like this. So that means the concave opens down. Okay, so now that you know that what we need to look for is the a, so when you look at this a right here and it's negative, your parabola looks like this. Therefore, you're going to have a maximum value because it's a maximum right there on the tip top. Here, a is positive, so your parabola looks like this. You're going to have a minimum value. Here, even though it's a fraction, but it's still a positive fraction. A is positive or greater than 0. So you're going to have a minimum there. A is negative, looks like this. So your parabola is going to have a maximum. We're almost done. Now, the vertex form. We are very familiar with this, and it's really user-friendly when you're trying to graph a function in vertex form, because this is what we use for transformations, how to do up and down, side to side, and all that. So, and a, again, needs to be different than 0, because otherwise it's not a quadratic function anymore. So a is the leading coefficient. Same way as the standard form. So a is always the number right there in the front. Now, the vertex of the parabola, you already know, is h and k. H and k. This minus right here belongs to the formula. I know you remember that. So the equation for the axis of symmetry is always x equals whatever the x from the vertex is, or whatever h is. I talked about that in the previous video. So if a is greater than 0, then k is the minimum value because your parabola looks like this. And then if a is less than 0, or if a is negative, then you're going to have a maximum because your parabola is going to look like this. So for the parent function, the vertex is located right there at 0, 0. And it is a minimum. And then the axis of symmetry is a straight line that divides the parabola in two equal halves. So this is the axis of symmetry right here. Axis of symmetry right here. And it's a straight line. It's a vertical straight line. Goes up and down, up and down. And for the parent function is located at 0. That's what we have in this case right here. Now, a quadratic function increases on one side of its axis of symmetry and decreases on the other side. So in this case, it goes down, 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 and then decreasing, right? And then right at the vertex or the axis of symmetry, and then it switches direction, and then it goes right back up. Okay, so now we need to answer the interval where the parabola is increasing. Well, it's increasing from here up, from the axis of symmetry down this way. So from 0 to positive infinity, that's where it's increasing. And it's decreasing from negative infinity all the way up to 0. So from negative infinity all the way up to 0. In this case, that's a little backwards. But, once you have the graph, you don't have to worry about it. Just read the graph. So increasing interval, it's increasing from negative infinity all the way up to 0. So negative infinity to 0, that's increasing. And decreasing, it's from 0 toward positive infinity. That's going down. So from 0 to positive infinity, that's decreasing. So the vertex form examples. So remember from the previous page, we have y equals a x minus h squared plus k. This minus right here belongs to the formula. So we need to pull the information from the vertex form. So the vertex, I know it's h and k. So this is h, this is k, and this is a. Okay, so the vertex is h and k. H is 4, k is 2. The axis of symmetry is the x from the vertex. If this is the vertex, this is the x, so x equals 4. If you were to sketch the graph of this parabola, you need to look at A. A is positive. Since A is positive, your parabola is going to look like this, and it's going to have a minimum. So the A value is that right there. So that's 2. Now the concavity, does it open up or down? In this case, because A is positive, it opens up. And the last one, this is A, H, and K. The vertex is H and K, but remember the minus belongs to the formula that makes H -1 and K is just -7. The axis of symmetry is a vertical line, so x equals, and it's x equals the x from the vertex, so -1. For you to determine minimum or maximum, you need to look at A. A is positive, that makes a smiley face. Smiley face, you have a minimum. A value is right there, 3. Concavity is positive, so it opens up. Now I have another video for page 7, and it's all these calculator tricks on how to find all the x-intercept based on the graph given. Bye.